All right, so now we have a couple other examples I want to work with. Just remind you when you see these. So for instance, what if I'm going to keep simplifying? That's the only really the directions. Do you notice in math, if it's an algebraic expression or something like that, simplify is what they normally say. Just means make it in the simplest form that you can. So here I get the square root of 125 minus 3 root 5. Now remember the rules of addition or subtraction of radicals. Each term needs to be in the simplest radical form, and in order to add and subtract, they have to have the same number underneath the radical. So looking at this, is 3 root 5 at least in the simplest radical form?
Yes.
All right, but we know the square root of 125 is not. Guys, what does the square root of 125 simplify down to? So that's 5 root 5 minus 3 root 5.
2 root 5.
Now the radicals, once we're in simplest form, remember the radicals are kind of treated like variables. Now I go, all right, do they have the same radical behind them? Yes. So I know I can combine the coefficients out front. So it's going to be 2 root 5. Now let's look at one more. What if I do this one? Let's go the square root of 200 minus 5 times the square root of 75. All right, now again, I know neither one of those radicals in the terms of that algebraic expression are going to be in simplest form. But what's the first one going to be? 10 root 2. What's our second one going to be?
25 root 5.
25 root
3. My bad.
3, right? Because perfect square number is 25 that comes out. Looking at that, I've simplified each radical. Can I go further? So that is your simplest form. Because they're not alike radicals, I can't combine them. All right, another thing you need to remember, this is just a sidebar. When you multiply radicals, please think carefully about this. Like if I have 3 times the square root of 3 times, let's say 4 times the square root of 5. What parts are being multiplied together? Well, careful.
3 times root 3 is being multiplied by.
The things that are going to be similar to each other. If you're multiplying radicals, you better do it right. And what I mean by that is what you multiply together are going to be your coefficients are what multiply together. So you get 12. And what's underneath the radicals get multiplied together because they stay underneath the radical, which is what?
15.
15. And then I double check it. Can I simplify any further?
No.
But you need to make sure radicals are what get multiplied together and the constant terms are what get multiplied together. You don't mix the two. You don't go 3 times 5, the square root of 5. That's not what's happening. You can't combine them. All right, last one that we need to make sure that we remember. Again, the directions are going to be really simple. And this happened about this time last year in your Algebra 1 life, okay? And it's working what's called rational expressions. And the problem was like this. 5 divided by the square root of 7 minus the square root of 2. Simplify that. It should have been right away like a freak out factor when you were, and you're like, oh wait, there's 2 radicals there. So, instant reaction would be like, all right, I'm going to multiply everything by the square root of 7, and then I'm going to multiply everything by the square root of 2.
Oh, yeah.
Now,
No,
is that
no,
going to get
no.
rid of your radicals?
No.
No. This is a binomial, correct?
Yes.
All right, so I have 2 terms. How do we get rid of this?
Multiply it by square minus square.
Square.
The total.
No, if I square the total, watch of this side. If I square the total, you're going to get a root 14 in there, correct?
Oh,
so
no.
you get 7 minus 2 square root of 14, and then you get minus, excuse me, it should be a positive 2 there. So you'd end up, so does that get rid of the radical if I square? So somehow I have to get something that works with it. So what you're going to have to do, you're still going to have the idea of multiplying by a binomial, but it's called the conjugate binomial. You're going to want to multiply by the exact same thing, but notice what did I change? Because now I changed that to a plus. Why? Let's go over to the side and try it real quick. I have the square root of 7 minus the square root of 2 times the square root of 7 plus the square root of 2. So if I FOIL it, outside, front first, root 7 times root 7 is 7. Outside, I get a positive square root of 14. inside a negative root 2 times 7. Oh, that's a negative root 14. Last, that's a negative 2. What happens to that middle term this time?
Oh my goodness.
So your answer is 5. So when you're doing that, and since we did it off to the side, I'm going to save us a little time. Distribute the numerator, so you get 5 root 7 plus 5 root 2. And this is all going to be over what?
5.
Because if I use what we know, it's going to be 5. Can I keep simplifying it further? Yeah, what we're going to have is going to be root 7 plus root 2.
That's funny.
Miss Gretchen,
That's, to me, that's fun.
That's undeniable.
Miss Gretchen, you're
That's
just
really
like,
fun. Now, all of those things you had last year, you're going to be expected to know. So today, what's going to be your worksheet like? Your worksheet's all about radicals and equations of lines. Can you see that I'm still going back to these equations of lines?